All right, we will get started here. Once again, good day, everybody, and thanks for joining the Digital Thread Series webinar today on Quality Engineer. Let's look at the agenda for today. I will do a quick introduction of myself and PDSVISION, go through the topic overview, what Digital Thread is in the PLM environment, and then the quality engineer in the digital thread environment. And then under quality, we will go through CAPA, which is corrective actions and preventive action, which is the exercise that the quality people will follow to capture the quality issue. And then we'll also go through the change management, but we will look at the change notice that is being created through the CAPA itself. And then we will look at the BOM red line, which is a new function that PDZ has introduced as part of Winchell 12 on. Tool that I find to be very, very helpful and great for the change processing and redlining. And then we'll quickly talk about non-conformance and customer experience. And right at the end, we'll have a question and answer session. Right, my name is Ephraim Puyeng. I'm a PLM manager at PDSVISION US with over 8 years experience on PDC products, specifically Winchell modules. I am a certified Winchell implementer and trainer. A bit about PDSVISION. We are formerly Boundary Systems, and just looking at the bottom part, there is just the history of the organization. So Boundary Systems was founded in 2006, while PDSVISION was founded in 2008. And then Boundary Systems became a PDC's preferred Winchell partner in 2009, 2010 around there. And then in 2014, they expanded their global operations into South Africa. Then in 2018, Boundary Systems was acquired by PDSVISION. We regard ourselves as the technology leader, being the first PDC global reseller and preferred service provider. We offer capabilities in consulting, implementation services. This is setting up Winchell from the beginning, from scratch, doing the upgrades, migrations if needs be. If there's any customization that we need to build for the customer, we offer such services. Professional training, be it remote or in person, in our offices or at the customer side, we offer such training on the products that we offer. And then we also have the cloud service, where we basically host some of our customers. So if you need a hosting for any of your professional services, we do that. And then we also offer the help desk support, and you would see PDSVISION branches are spread across the world. If you look at the map on the right there, that is where you would find all our entities. So we offer support throughout those time zones as well. Some of our strategic partners and solution providers that we work with, PDC is our main partner, but we also partner with these companies listed here to make sure that we bring our customers a comprehensive solution that addresses their needs. Right, so just to talk about the digital thread concept, this is a concept that kind of brings in the different areas of your companies to work together digitally in one PLM tool or one PLM system with the same information as well as the same processes to follow. It is essentially the use of digital tools and representations for designing a product, evaluating that product, so checking the quality of the product itself, and making sure you manage the whole product life cycle from inception up to retirement. And it simply creates the traceability and governance of that product data across the company. So if you look at the picture here, it's basically 4 rings of digital thread. So when you begin to deploy your product in a PLM environment, you normally start with, from the inner ring. So where you basically manage your CAD, your documents in there. And then as that process sort of matures, you then move on to the second ring, where you basically include things like change management in there, quality, things like bond management, and then you move out to the third ring, and then eventually the final and the fourth ring here, which is basically the IoT, where now your product is out in the field, and you're basically monitoring how it behaves, as well as how it's been used. Is it used as it should? And also, is it performing as it should? And then that information sort of get fed back into an IoT system, and that information could be used to build a better version or a better next version of that product. So those are the 4 sort of key rings for your digital thread. So this is our 7th session of digital thread webinar that we have been running. If you missed the 6, the first 6 of this, you can always go to our YouTube channel to rewatch those or to watch those. So this is the 7th one, and there is 2 more to come. So please stay tuned for those as well. The one is on technical publication, how you would go about creating the technical pub information for your product. So things like training manuals, if you need to train people on how to use the product, operation manual, that sort of information. And the last one is on aftermarket product service. Basically, how do you service and maintain this product once it's out in the field? So things like the service bill of material for that particular product, things like replacement components, your bill of materials, the toolkit that are necessary to maintain. It will be the last webinar that will present to you. So getting back to the topic, we know developing products today create many challenges across development cycle. So we find more complexity, more complex products, and we take these products and deploy them in more complex environments as well. And then you also have multidisciplinary teams working across or around the globe and in different time zones. How do you make sure these people are working at the right information at the right time? At the same time, we are seeing rapidly maturing and changing industry regulations for safety and security standards, which happens every now and then. Finally, everyone is concerned around delivering the right cost, the right quality, and productivity across the enterprise. So how do we identify the early problems in the system and come up with the solutions for those? And also, how do we accelerate product development within an increased collaboration? Because that's where the whole product development is moving now. We need to collaborate in order to make sure that we get the product out the door quicker than our competitors. Okay, so to be able to drive those benefits to your organizations, the digital thread is used to connect your product across the product development lifecycle, including all your upstream and downstream processes in simply one system, a single source of truth, enabling digital thread across the enterprise, and it creates continuous access to product data. So throughout this lifecycle, everyone who is impacted or is working on the product development, they can access and see and have a window into the product development data and be able to use it at the stages where they would need to use it. So in today's session, we will focus on the 3 parts of the digital thread, which is the car part that we talked about, corrective action, preventive actions, and the change notice for change management that we will create as part of this kappa. And then eventually, because you would have made changes based on the issue that was reported in quality, you will then have to update your bill of materials to accommodate the new changes that addresses the issue. And but basically, things that are used to help drive value and improve quality of your product design life cycle. Now, let's look at the change management part of the process, and we will focus at the capabilities around BOM redlining. So some challenges that people have in change management, it is not always easy to understand the goal of the change so that everyone can easily review it and approve it. That information is not captured properly to show what is the intent of this change. What are we trying to, what are we changing here? So and basically, how do we create an out of change without creating lots of rework? Because now we can graphically, through this BOM red line, see exactly what needs to be changed and be able to see those in a graphical format as well. It helps, and it also helps if you need to go back and see and check why the certain component or a certain bill of material was changed. You can go back and view this and also view the red line that was made to make it easy for you to see this information. So the BOM red line simply allows you to plan and execute the BOM changes. So it lets the team also review the changes before they actually committed, before we can actually apply them. If you're looking at the picture, the first picture here, you'd see that is what BOM redline gives you. We can see exactly we're planning to remove that particular component. We're adding quantity on the connectors there, and there's other item at the bottom here that we're replacing with another one. So by looking at this, I can tell what needs to happen on this. And if I know what needs to happen with a particular change, and I look at this, I'll be able to tell if this is the correct representation of what needs to happen or not. So Winchell then gives you a redline editor that could be used within a change notice to basically create these markups. And once we're happy with these markups, you can easily apply the red lines at that right time. So simply in this case, if I go in and revise this bill of material, revising it, it will automatically commit these changes for me. Remove that item, replace the one with the other one, and applies it. So this basically enables the out of order changes where we're applying exactly what we needed to do at the appropriate time. Right. So to kick off our quality demo here is we first need to identify the component with an issue. So we've got a drivetrain here where we have an issue with the shaft there. Basically, what happens is when this car is driven for about 30 minutes or so, that particular gray shaft in the middle there sort of deforms. And we have since established that that is because of the poor material used to manufacture this particular component. So we're getting this component from our supplier. So we're realizing that the material used on this cannot stand the heat that would have been created by a vehicle at that time. And then it sort of causes this particular part to deform. So once I've established this information as a quality engineer, what I'll then do is I'll have to create a kappa for this. Kappa being a corrective action and a preventive action. So what are we correcting and what sort of action we taking to correct this? And what are we preventing if this is just a preventive sort of action we need to take? What are we preventing and how are we preventing it? Or a kappa could have both corrective and preventive action. So what it captures in details is the site information, where the actual issue was picked up, where the quality check was being done, and then the issue was picked up. And then the one powerful thing about Winchell kappa is actually captured in the second part there, the affected objects. So normally in typical quality systems, they would capture kappa in one system, and then they would only reference a number, a part number that they're capturing kappa to. That particular number or that particular kappa is not really physically connected to the part or linked to a part in any case, because the information or the bomb information is usually captured in a different system. So the power of this kappa in Windshield is I can basically capture the exact EBOM part or the exact bill of material component, engineering component, or a document that represent my affected object, or that is affected as part of changing this. I can literally go and link that particular component with this directly to my kappa here. So I'm gonna go and just show you how you would normally do this in Windshield. So we are about to create a kappa, but we first need to identify and find this component in Windshield. So this is the component that we're looking at, and we're looking at this shaft here, or shaft assembly here, with its parent assembly. And we're looking at this because the change is going to also affect this high-level assembly, or the parent assembly for this component. So we'll go ahead into the quality module and start creating the kappa for this. So in Windshield, it's called a kappa request. So I'll go in and give it a name. There's some of the information that's already auto-populated, like the requester of the kappa, and then the file it was created. So we've given it a descriptive name, and then I'll go and add a description to explain exactly what happens. This is the part that deforms after driving this vehicle for this long. And then I can also go in and put in additional information that goes with this. So in this case, we're just capturing now the description there, and then I will then go in and capture the additional information to say we have done heat analysis on this and put this under a certain heat, and then we can confirm that the material deforms under that condition. And in this case, this is a sort of trend we have been picking up from this supplier of ours. Some of the components we get from them in the past, we have been having issues where there's a material deform issues there. So we've already investigated that information, and we're capturing this as kappa, and then I'm just capturing a reference ID that we would use for this. And then I'll go and pick a plant where this happened. This happened in Johannesburg plant. And then we can go and add information about the personnel that we could reach out to who was doing this quality check and have this information for us, or as our primary contact for the quality information. So it's John Evans in this case, our quality engineer on the floor. So we have that information picked up. He is the person who initially reported our issue in this case, but you've got those options that you can pick depending on how the issue was reported. And this will be our primary contact. The next thing we do is to add the affected objects on here. So we'll pick that components, the shaft components that's giving us a deformation issue. And then we can, if we've got this information, serial number, your batch number for this, you can also add that information or capture it in here. So there's a quantity of 100 that we have in stock. If I have things like purchase order for this supplier or the supplier number, I can also capture that information as well. Then the next thing is the actions that we're going to do now to correct. The first one, because now we're dealing with the supplier, it will be a supplier corrective action, or popularly known as SCA. And then this is the action that we're taking. We're going to return this part back to this supplier. So that 100 unit parts, we're taking them back to this supplier. And what we're going to do, because we have picked up a trend of the supplier giving us poor material components, we are going to mark or note them in the Windshield system as they do not use supplier for this particular component here. That is the first action we're going to perform. And the next one is to correct this issue we currently have internally now. And how we would now correct this is we're going to change the supplier. That is the decision that we've taken. We're going to change the supplier, And then once we've gotten the part, we then going to update our bill of material through the change process with the new part that we have from our new supplier. That is the second action that we're going to take. And then there will also be the third action where we now preventing this from happening again. So the first measure here would be that we are going to stop assembling this particular components or shaft onto the vehicles that are already on the assembly line. So we're going to stop until we have gotten the new part from the new supplier. And then once I've captured that, I'm going to go back to the corrective action that we're taking. And then because we're going to update the bill of material and we need to do it in a formal way, so I'm going to tell the system to create a change notice for me automatically once I've completed this. And then I'm just specifying where the change notice is and then the template that I'm using. And then I'm picking on the part that is going to be affected by this change. And then I've completed that. Now I'm just completing my kappa. I need this information that I've missed here. So the subject of this would be supplier. So it's an issue with the supplier here. And then it's a kappa that you bring in there. Then once our kappa is now created, we can go in and look at the information on this kappa. This is where you'd find information on this kappa. We can see that the next section on this kappa is for someone to go in and review it. We can see the affected objects on this. I can also go in onto the structure of this and see all the information attached or captured as part of this kappa. And then if I go to the associations at the bottom here, I can also now see the change notice that I have created. So I can now go into this change notice because it's not submitted yet at this stage, it's just created. I'm going to go in and then also add additional items that are affected by this change. So for an example, the parent assembly of this, it is the highest assembly impacted by the change. So I'm going to go find that assembly in the system and then bring it in as part of this change. So the other information that's is not really necessary, but it's some information that you can capture is how you would disposition an affected objects. Are you gonna scrap it, rework it, or reuse it, or use it as is? That's basically what we have captured on this. Then the next thing that we would then need to do is now go and create a BOM red line for a change notice. Okay, so we've now added that top level assembly, and then this is the component that we change in the 7300 that we need to change that assembly or replace that assembly with a new shaft assembly. So the first thing that I'm going to do is go create a red line. So basically communicate what needs to change in this case. So I've got my assembly here, top level, my highest level assembly affected by this change. So I'm going to go and now identify the part that we need to replace on here. So I am going to go in now and then using the windshield replace function, I'm going to replace it with the existing component. If you don't have a component in the system already, you can go in and replace it as a new component and then create a new component with its new supplier. And now we're going to pick a new component that we need to replace this with. Sorry, I think we're replacing the wrong component here. We need to be replacing 73,000 number. So we'll go through the exercise again, the replace function, replace with existing, because we already have that replacement components in the system for the new supplier we need to use now. And for the purpose of this demo, I just appended the underscore new for the new component on there. And then you'll see our BOM red line shows us now what's going to happen. This hasn't happened yet. It hasn't been applied yet. So it just shows you that we're going to replace this with that other component. Then we check this back into the system with this new red line. And if I go in and refresh my page here, you'll notice that first component and the change summary table, you now have open next to it. It shows that it's got a red line, so someone who's reviewing this can open that and they can see what's going to be changed here. Then we go in and we submit this change notice so that the workflow can start. And we'll go in as the person who needs to complete the task here. And then the task is fairly simple. They simply need to revise that top level assembly, and then it will automatically apply the red lines that we've just done now by replacing the new component. So from the affected objects, you will simply pick the top level assembly affected by this change, is the 70,000 in this case, and then revise this component. Okay, then the revision goes up from A to B as a new revision, and then this is for a change. Our release target is for a change, and then you'll see this is now on B1. And we complete that action, and then if I quickly show you, we can still go back and look at the change. So if after 10 years we're going to go back and see why, what was changed, what was the goal for this change, you can always go back and look at these red lines. They stay with the change forever. Now I'll go into the latest one we've revised and look at the changes that we've done. So I can do the BOM compare between the two revisions and see exactly what had changed of that. And I can also go into the BOM structure of this to show you that by just applying that the revise action, our new component is actually being added to this. The changes that we've done in the BOM. As soon as we commit, those are automatically applied onto our assembly here. Now that we got this correctly, we're going to go back to, then this is the functions where we will add your approved manufacturers and set them as approved or not approved. Now we'll go on and now complete our change process here. So I'm just going back to my change workflow in here, and then I'm just completing these changes. And something to mention is the responsibilities for these roles that we completing now can be done by different people depending on the organization. So then the last action we need to commit here is the audit to make sure that everything is being applied as is, and then we complete that. Once that is done, it then resolves our change notice. Our change notice is now done. So at this stage, what I can do is go back to my assembly where we've added a new component to it. And what I'm going to do is go to that component and basically set the supplier as our approved supplier going forward. So we have this supplier as a preferred supplier for the longest time, but we're happy with the service we're getting from them. Now we will go in and change the Elliott Manufacturing to be our approved supplier. So anyone who's looking to purchase this, they can quickly go into this and then see who is our approved supplier for this. And you can also set the ones that we shouldn't go to at all. Right, now I'll go back to my CAPA and then just follow the steps to complete the CAPA here. So basically, CAPA review, you go in, you review the CAPA, you add any detailed information about the CAPA. So the outcome of our evaluation could be that we accept this as a proper change. We don't need further investigation for this. You can put in the comments in there, and then you complete the activity. So I'll quickly go through the process of completing the tasks in here. So depending on how your CAPA is configured or what sort of actions you've required as part of the CAPA, the process could be quite long because it goes through all the different roles at different stages of the CAPA. So at this stage, we basically confirming that this CAPA was actually effective. And then once you've done that, the CAPA is set to closure. So this is just to see that the CAPA went through all the steps here, and then it was eventually completed. So at this stage, our CAPA is completed. We are ready to now use the new component in our system or edit in the system there. The next two things I want to talk about is the non-conformance. So non-conformance could be captured in the system. So for the people that do not know what is the role of non-conformance, non-conformance could be used where, let's say, we were supposed to manufacture using material X, and then we realize that there's a backlog in getting material X in, then we're gonna have to use material Y, which is still a good material to use, But then because we have deviated from the initial requirements or use of a specific material, you then have to file a non-conformance for that. The reason we're doing that is because if there's audits and then we need to go back and see why we use material Y over material X, we can always come back to the non-conformances here and check why that was the case. And then if needs be, you can also create change notices from the non-conformance. That is the sort of information you can capture from this. And then Windchill, it's so customizable in the sense that if you need to capture certain information that's not captured in an out of the box interface here, that can be created and customized to have that additional attribute or parameter to capture information. Then the next one is the customer experience. So basically, this is the customer complaints in a simple form. There's complaints that are coming from the customers. The reason why it's called customer experience is that it could be complaints. It could also be improvement suggestions that are coming through to say if this has to be done this way, it might be better for our customers and things like that. So this is just capturing that information. And if your system is open enough to cater for your customers directly, customers could be trained to create these customer experiences themselves. Or there could be an admin person who receives emails from customers in terms of the complaints or the suggestions, and then they capture those in the system against certain affected objects as well. So your data is linked. We can see if I search for a certain component, I can see what sort of customer experience we're logged against that, what sort of CAPA, what sort of non-compliance were logged against those. And then that is the basic workflow that the customer experience would follow in this case. That is all I wanted to share with you as far as quality goes for this particular webinars. There's actually more things, there's actually more modules that we could cover as far as quality goes. And again, if you're interested in some of those, I mean, you can simply reach out to us. I will put out our sales information and my information up again on the screen in a short while. So at this stage, I will also take questions if there's any questions. Questions could be typed into the questions section of the webinar itself. Yes, so I will get to the questions if there's any in there. Yeah, so just for information there, if you have any technical questions beyond this webinar, you can reach out to me directly at the email address ipoyang@pdsvision.us. Any sales query, if you need a demo, you want to trial something that we've shown or you've seen throughout our digital series, sales@pdsvision.us will be able to assist with that. Any information could be accessed from our pdsvision.com website. And then please also follow our PDSVISION YouTube channel. This is where this video as well is going to be uploaded to in due course. So if you wish to revisit the video and rewatch it, it will be available there once it's loaded in. I see there's no questions at this stage. I want to take this time to appreciate your attendance and thank you for attending today's session. And as I said, there is 2 more webinars on digital thread that are coming up. Please be on the lookout for those, and I would encourage everyone to attend those ones as well. So thank you so much for attending, and have a good of the day. Thank you.